Okay, so this is part 2 of section 4-2, and we're looking at periodic functions. Just a reminder, we talked about this a little bit already, but for sine and cosine, their period is 2 pi. And what we mean by that is that's how long it takes for a cycle of their graph to complete, and then after that, they just keep repeating the same values. It's also 2 pi for cosecant and secant. However, tangent and cotangent have a period of pi. Those are the only ones with the shorter period. And so what this means here is we were using this in the last examples in part 1 of the video, but if I have an angle here, I can add or subtract 2 pi as many times as I want, and it's still equal to that angle. And that's what we were using in those examples where maybe I had sine of let's say 405 degrees, and we subtracted 360, and that's going to be equal to sine of 45 degrees, which is 405 minus 360. So that's what we're saying with these periodic properties here. Now, we're going to go ahead and evaluate some angles on the unit circle. And the nice thing about all of these angles is they're ones that we have to have memorized already for the unit circle. So sine of pi over 3 is going to be root 3 over 2. Again, that's one on your unit circle that you've got to have memorized. Cosine of 5 pi over 4 is going to be negative root 2 over 2. Again, one you have memorized. And then tangent of 3 pi over 2. Now we don't have tangent memorized. But what we do know is that tangent is either, we can say the y value over the x value, or sine over cosine. Okay, so using those, we know that sine is -1 there, and cosine is 0. Well, we can't divide by 0, so that means tangent of 3 pi over 2 is undefined. For cosecant here at the bottom, cosecant of 5 pi over 6, well, we know that that's the reciprocal of sine, so 1 over sine is cosecant, and that would be 1 over 1/2, and that would be 2. Or it's the reciprocal of sine, you can think about it that way as well. Now looking at these next examples, these are still things on the unit circle. These are still angles on the unit circle, but now we're looking at tangent. Tangent of 11 pi over 6, well, that would be sine over cosine. So -1/2 is the sine value. The cosine value is root 3 over 2. If I multiply by 2 over 1 and 2 over 1, denominators cancel out, and I have -2 over root 3. But then I need to rationalize, not 2, so 1. I need to rationalize that, so I multiply by root 3 over root 3, and I have negative root 3 over 3. Now here, we can use those properties, the even and odd properties that we looked at on the previous page, and this is going to be equal to tangent, or negative tangent, of 11 pi over 6. So just multiplying this by a negative gives me positive root 3 over 3. Okay. Now this next example is a little bit different. It's saying to use an identity to evaluate. We're not using a calculator. Well, we know that this cosecant squared x is going to be equal to, or I'll just write the identity over here, we know that that's true from the Pythagorean identities we looked at. So I can replace this with 1 plus cotangent squared of pi over 6, then minus cotangent squared of pi over 6. And what happens is these are going to cancel out. Our answer is just 1. No calculator needed. Looking at these last couple examples here, we can evaluate again without a calculator. Well, cotangent of 5 pi over 4, that's just going to be the reciprocal of tangent there. And so that's going to be root We have negative root 2 over 2, that's the cotangent value, I'm sorry, the cosine value, over, I'm trying to do a fraction here, negative root 2 over 2, which is the sine value. Well, anything over itself is just 1. And looking at the next one, sine of these negative pi over 4 plus this huge value here, this is a multiple of 2 pi, so I can just get rid of that. This is going to be equal to sine of negative pi over 4, which is equal to negative sine of positive pi over 4. Sine of pi over 4 is root 2 over 2, so this is negative root 2 over 2. And let's go ahead and move on to the next page, to our last examples. We're again using the properties that we know to evaluate. And here we have sine of pi over 2. Well, that's going to be 1. If you use your unit circle that you have memorized now. And then 9 pi over 2. Well, 9 pi over 2 minus 2 pi, which we can rewrite as 4 pi over 2. It's going to be 5 pi over 2. We can subtract another 2 pi. We get pi over 2, and so we know that this is also 1. And now we're going to use a calculator, and we need to be really careful here with noticing that this number, 3.7, is in radians. Okay, so we need to make sure the mode of our calculator is in radians. And let's see if that helps. There we go. So go to mode, and we want to make sure it's in radians. Good. We can get out of that. And now we're going to evaluate this. So tangent 3.7, press enter, and we're going to round that answer. So I'm going to write 0.6247. Okay. And then we can evaluate sine, and your calculator can type in pi, so we have 3 pi divided by 10, and we can write that. And that brings us to the end of section 4-2 and part 2 of the video.